Hi, today is a Friday, August 7th, 2026. Yesterday, we had a meeting with a Singaporean delegation who was looking for big AI data center and possible site to build their own data center in Korea. And they speak Chinese, so I could understand like 30% of what they are saying at the meeting table. Of course, I could understand what they are saying in English, although I prefer the Chinese because I am learning Chinese. But regardless, let's learn English as with other days by reading several English articles each day with a focus on exact pronunciation and instant pickup of knowledge and memorization of key words, expressions, cliches, or sentences that I myself deem good or that could come in handy when we interact with foreigners, just like a meeting we had yesterday. By the way, I'm a KT manager and I work for Korea Telecom, KT, the number one carrier and number one AI service provider in Korea. You have to meet us, visit us. You don't have to go to any other places, right? AI data centers, often called AI factories. Okay, so AI factories are highly specialized facilities built to train and run massive neural networks rather than perform general purpose computation. They prioritize ultra-high density GPU computing, ultra-low latency optical networking, and direct-to-chip liquid cooling. Ultra-low latency optical networking. They prioritize ultra-high density GPU computing and direct-to-chip liquid cooling. Those are good expressions, right? Direct-to-chip cooling. Direct-to-chip liquid cooling. Ultra-low latency optical network. Ultra-high density GPU computing. Perform general purpose computation. Train and run massive neural networks rather than perform general purpose computation. Direct-to-chip liquid cooling. Direct-to-chip liquid cooling. Ultra-low latency optical networking. Ultra-high density GPU computing. Right? Ultra-high density GPU computing. Ultra-low latency optical networking. Direct-to-chip computation. Right? Well, I was trying to blow my nose because my nasal cavity has a runny nose. To visually grasp how these facilities differ from traditional service spaces, here is an illustration highlighting the architectural shift. Understanding the design and engineering requirements of these modern facilities requires looking at several core areas. High density processing. While traditional data centers rely on CPUs to manage various discrete, sequential tasks AI clusters depend on hundreds of thousands of parallel processors, such as GPUs, TPUs, and custom accelerators. Right? GPUs, TPUs, and custom accelerators. These processors require vast parallel datasets and operate at incredibly high temperatures. 2. Radical power architecture. AI racks draw significantly more power than conventional configurations. Where legacy racks draws 5 to 10 kilowatts, AI racks can demand 100 kilowatt or more. This necessitates high voltage distribution. Using high voltage direct current such as 500 V to reduce current, copper usage, and conversion losses. High voltage distribution. Using high voltage direct current. Wow, high voltage direct current, right? High voltage distribution. Using high voltage direct current such as 500 V to reduce current, copper usage, and conversion losses. Modular power blocks facilities must be designed with scalable modular power blocks so power can be seamlessly expanded without disrupting operations. Massive grids. Modular power blocks facilities must be designed with scalable modular power blocks so power can be seamlessly expanded without disrupting operations. Massive grids. Proximity to robust green or modular energy sources is often required to offset the immense continuous power draw. Proximity to robust green or nuclear energy sources is often required to offset the immense continuous power draw, right? Massive grids, nuclear power, modular power blocks, high voltage distribution. 3. Advanced cooling systems. Because AI chips are so dense, traditional forced air cooling is no longer adequate to extract the heat flux. Modern designs incorporate direct-to-chip liquid cooling. Fluids are pumped directly to microchannels on the silicon, making it the industry standard for high-performance computing. Rear door heat exchangers. Specialized doors equipped with liquid cooling loops fitted onto the back of the server racks to remove heat. Rear door heat exchangers. Near zero water use. Many facilities integrate chillerless, closed-loop warm water systems to improve power usage effectiveness ratios. Often targeting PUEs close to 1.10 power usage effectiveness, near zero water use. Many facilities integrate chillerless, closed-loop warm water systems, right? Closed-loop warm water systems to improve power usage effectiveness. PUE, right? PUE, PUE, power usage effectiveness ratios, often targeting PUEs close to 1.10. So that's a chillerless, closed-loop warm water systems, right? Chillerless. Near zero water usage. Chillerless, closed-loop warm water systems. 4. Ultra high speed fabrics. AI model training requires massive amounts of data passing continuously between chips. Because of this, networks are built with incredibly low latency fabrics. Technologies like NVLink, InfiniBand, right? IB band, right? IB cable, right? InfiniBand cable. High-speed optical interconnects are used to tightly orchestrate GPUs so they act as a single massive supercomputer rather than separate servers. NVLink, InfiniBand, right? I heard InfiniBand once, NVLink, InfiniBand, high-speed optical interconnects. Further look at how data centers are adapting their networking and cabling setups for artificial intelligence data centers versus AI factories. 5. Facility management and digital twins. AI facilities are increasingly managed by scalable software that utilizes digital twins, virtual replicas of the facility that monitor the environment in real time. This allows for predictive maintenance, leak detection in the liquid cooling network, and the dynamic allocation of workloads. To learn more about industry concepts and standards for constructing these centers, you can explore the following resources. IBM is one of the renowned knowledge centers, right? Understand the core definitions in the IBM AI Data Center Guide. Read the comprehensive Juniper Networks AI cluster design documentation. Learn about the architectural shift on Hanwha Data Centers blog. Hanwha, right? Get an overview of modern infrastructure in Medium's AI Data Center article. Hanwha is one of the largest corporations in Korea, right? They're a good company. I worked with them. I recommend them to you. They're a good company, right? So this is AI generated articles combined together one. If you would like to explore this topic further, let me know. Are you designing a specific hardware cluster or researching facility level cooling? Would you like to know more about the software networking layers? Example, InfiniBand versus Ethernet. Tell me how you would like to narrow down the design process. Cisco Systems, what is an AI data center? What is an AI data center? Cadence, Hanwha data centers. Ingenious build, right? So from this article, we learned several expressions like NVLink, InfiniBand, high density, high speed optical interconnects, ultra low latency, optical networking, ultra high density GPU operations, and what else? Direct to chip cooling, discrete clusters, slow networking, sequential GPUs, NPUs, and AI accelerators, chillerless, closed-loop warm water system, chillerless, warm closed-loop warm water systems. But to be sure, let's go back to my storage. NVLink InfiniBand high-speed optical interconnects. Right. So I skip it. Chillerless closed-loop warm water systems to improve power usage effectiveness, or PUE or PUE, power usage effectiveness. Train and run massive neural networks, general purpose computation, ultra high density GPU computing, ultra low latency optical networking, direct to chip liquid cooling. Yep, that's my office. I just raised my legs onto the top of my table. I just ate 3 eggs and sipped 糯米香 cha from China. I bought it in where? In Kunming last year, right? It's a round, cylindrically shaped tea packets of tea, and they smell of rice, right? 糯米香, xiang means smell, flavor. 糯米, mi is rice. 糯米 means sticky rice smell. Thanks for listening. Have a great cha day or tea day. Bye bye.